Hello students, so we have completed the properties of inverse trigonometric functions. Okay, let's solve some problems. Okay. First problem is you have to show that sine inverse 2x root of 1 minus x square is equal to 2 sine inverse of x. Now this x is lying between minus 1 upon root 2 to 1 upon root 2. Okay, now here we have to take this sine x to be, let sine x is equal to you have to do substitution for x, so you have to put x equal to sine theta. Okay, so that your theta is sine inverse of x. Okay, so we are substituting x equal to sine theta because here sine is there. Okay, when you want a result in terms of sine, you have to put x equal to sine theta. Okay, so substituting in RHS, so sine inverse 2 into sine theta root of 1 minus sine square theta. Okay, sine inverse 2 sine theta, 1 minus sine square theta is cos square theta, then cos square and root will go and sine theta into cos theta remains. Now this is our trigonometric identity, that is sine 2 theta, right? So sine 2 theta, okay, using the property sine inverse of sine of x, you will get this as 2 theta. Okay, and theta is nothing but sine inverse of x. So we got the desired result. Okay, this is the second question. Here now it is given cos inverse of x, so we want result in terms of cos, so you have to substitute x equal to cos theta. Okay, so theta is cos inverse of x. So RHS, substituting in RHS, you will get sine inverse of 2 into cos theta root of 1 minus cos square theta. Okay, so 1 minus cos square theta is sine square theta, which is sine theta. Yeah, so this is here you have to use 2 cos theta cos square theta. So same way it will be sine inverse sine 2 theta. Okay, using the property you will get 2 theta, so our theta is cos inverse of x. Okay, this is the required result. Next question is you have to show that tan inverse half plus tan inverse 2 upon 11 is equal to tan inverse 3 by 4. Okay, so start with RHS. So we have tan inverse of x plus tan inverse of y. So using the property tan inverse x plus y, so this is half plus 2 by 11 upon 1 minus x into y, so half into 2 by 11. Okay, so this is tan inverse cross multiplying, or you can take this as it is, so that it will be easy for the denominators to get cancelled. Okay, so here you will get 11 plus 4, so 15 by 22 upon 22 minus 2, so 20 by 22. Okay, so this gets cancelled. You will get tan inverse 15 upon 20, so 5 3s are 5 4s are, so this is LHS. Okay, tan inverse 3 by 4. Next question is, you have to show that or express tan inverse cos of x upon 1 minus sine of x in simple form. Okay, so here you have to make use of all the trigonometric identities which you have known. Okay, so we know that cos of x means you can write this identity in terms of half angle formula. So cos of x you can write it as cos square x by 2 minus sine square x by 2. Okay, then 1 minus sine x you can write it as 1, you can write it as sine square x by 2 plus cos square x by 2. Okay, and sine x you can write it as 2 times, that is sine 2x is 2 sine x into cos x. So in terms of half angle it will be 2 times sine x by 2 into cos x by 2. Okay, so the denominator you can write it as a plus b the whole square. So here it will be a minus b the whole square. Now our numerator is cos square minus sine square, so you have to write denominator in such a way that it looks like numerator. So our numerator is, and denominator is cos x by 2 minus sine x by 2 the whole square. Okay, this we can expand, that is we can use cos x by 2 minus sine x by 2 into cos x by 2 plus sine x by 2. Okay, so we can cut this one, sine x by 2 and cos x by 2. Now dividing both numerator and denominator by cos x by 2. So you will get, in the numerator you will get cos x by 2 upon cos x by 2, that is 1. Sin x by 2, here I will write dividing numerator and denominator by cos x by 2. Okay, so here you will get tan x by 2 upon 1 minus tan x by 2. Okay, now this tan x by 2, this thing is nothing but, this is your tan pi by 4 plus x by 2. Okay, if you use the formula of tan a plus b, what you will get? Tan a plus tan b upon 1 minus tan a into tan b, right? So in place of a I am writing pi by 4, and in place of b I am writing x by 2. So you will get this required result, tan inverse of tan pi by 4 plus x by 2. Okay, so tan pi by 4 is 1, tan x by 2 is this, 1 minus tan pi by 4 into tan x by 2. Okay, tan inverse and tan, so using the property of inverse trigonometry you will get the final answer as pi by 4 plus x by 2. Okay, so this is the answer. Next question is, you have to write cot inverse 1 upon root of x square minus 1 in the simplest form. Okay, so you have learnt about derivatives, right? So in those derivatives, we used to write derivative of cot inverse, sec inverse, okay, or we can use the knowledge of our trigonometry, that is x square minus 1. So in place of x, if you put some identity, okay, in place of x, if you put some trigonometric ratio, that is sec, cos or cot, what you will get? So here if you substitute in place of x, you substitute sec theta, okay, sec theta. So in place of x square minus 1, it will be root of sec square theta minus 1, which is nothing but tan square theta, using the identity. So we'll get tan theta, right? So if I put here cot inverse 1 upon tan theta, and we know that 1 upon tan theta is cot theta. So using the identity, you will get theta, which is nothing but sec square theta, sec inverse of theta. Okay, let's prove this. So tan inverse of x plus tan inverse 2x upon 1 minus x square. So we have to prove it equal to this. Okay, so I substitute x equal to tan theta. Okay, substituting x equal to tan theta, so your theta will be tan inverse of x, right? So our RHS will be tan inverse. In place of x, I am substituting tan theta, so 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Okay, so here you can make use of the identity, which is tan 3 theta. So tan inverse tan 3 theta, so you will get 3 theta, and theta is tan inverse of x. Okay, so this is 3 tan inverse of x, so you can split it, you can write it as tan inverse of x plus 2 tan inverse of x. Now 2 tan inverse of x we can again substitute using the property which we have learned in trigonometric identities, that is tan inverse of 2x upon 1 minus x square, and this is our LHS. Okay, so this is our required result. Next question is, you have to find value of this. Okay, now looking at these two terms, you will realize that this is nothing but using the inverse trigonometric properties. This is our pi by 2. This value is pi by 2. So cos pi by 2 is 0. This is the answer. Okay. Next question is from our miscellaneous examples. Okay, so I will just write this. Sine inverse of 3 by 5 plus minus sine inverse of 8 upon 17 equal to cos inverse 84 upon 85. This we have to show. Okay, so you have to start by taking the sine inverse 3 upon 5 as x. Okay, so our sine of x is 3 upon 5. Same way, sine inverse 8 upon 17, you have to take it as y. So our sine y is 8 upon 17. So these are two different triangles. Okay, first one is with the angle x. Okay, sine is 3 5 and this will be 4. Same way, second triangle is with angle y, 8 17, and this you have to find out. Okay, so this will be 17 square, which is 289, minus 64, to 25. So this will be 15. Okay, 15 square. So we have this information, we have to make use of this information. Now substituting x and y in place of this term and this term, you will get x plus y equal to cos inverse 84 upon 85. Okay, now I am taking this cos this side, so this will be cos of x plus y equal to 84 upon 85. Now we have to prove cos of x plus y as 84 upon 85. Okay, so using the trigonometric identity which we have learned in 11th standard, so cos of a plus b, cos a cos b minus sin a sin b. Now these values we know from the triangles. So cos of x is adjacent upon hypotenuse 4 by 5 into cos y is 15 upon 17 minus sin x is 3 upon 5 into 8 upon 17. Okay, now the denominators are same. So first you multiply. So this will be 60 minus 24 upon 5 into 17. Okay, so this will be 36 upon 5 into 17. So can't cut this. So this will be minus. This is minus, sorry. So this will be plus. You have to add them. Okay, so this is 84, right, and 17 5 it is 85. So we got our right hand side. Okay, next question. So here three terms are given: sine inverse, cos inverse and tan inverse. So I'll put this term as x, this term as y, and this term as z. Okay, so sine inverse 12 upon 13 is equal to x. So our sin x is 12 upon 13. Okay, and cos, from this you have to find out about tan x. Okay, we want every term in terms of tan. So using the triangle method, so this is 12 13 and this will be 5, right? So tan x will be opposite upon adjacent, so 12 by 5. Okay. Then cos x is our 4 upon 5. So tan x will be 4 5, it will be 3. So 3 triangle will be 4 5 3, so 3 upon 4. Cos y it is. So tan y is 3 upon 4. Okay, now using the formula tan x plus y, we will get tan x plus tan y. So tan x is 12 upon 5 plus 3 upon 4 upon 1 minus 12 upon 5 into 3 upon 4. So keeping the denominators as it is, you will get 848 plus 15 upon 20 upon 20 minus 36, right? So this will be a negative, so minus 16 upon 20, 20 gets cancelled, and you will get 63 upon 16, minus 63 upon 16. Okay, so this will be our 10x plus y. Now we have here z equal to tan inverse 63 upon 16. So our tan z is 63 upon 16. So we can write, we got this as minus 63 upon 16. So minus tan z as minus 63 upon 16, right? So our 10 x plus y is nothing but minus 10 of z. Okay, using the property of trigonometry, that is 10, we can write 10 of pi minus z. Okay, like we write sine and cos, so this will be 10 of pi minus z. So here it is 10 x plus y and this is 10 pi minus z. So from this we can write x plus y is equal to pi minus z. Okay, so this is nothing but x plus y plus z equal to pi, which is our required result. Okay.